Operational technology sits at the heart of modern naval vessels. From propulsion, steering and navigation to environmental, power and ballast control. Everything is dependent upon the security and integrity of operational systems. Whilst technology has simplified command and control, it also exposes operational systems to potential cyber attacks. Adversaries may seek to exploit cyber-physical attacks to cause damage to vessels, reduce visibility, or even take over critical systems. The impact of a successful attack can be devastating, both physically and psychologically. Protecting operational systems from cyber attack has historically been challenging. The attack surface is constantly changing. The proprietary nature of the technologies involved makes integration complex, and control systems are notoriously difficult to secure. Let's take a look at the anatomy of a potential breach. In this attack, we assume the adversary has done their reconnaissance and prepared in advance by exploiting an element of the supply chain. The use of transient assets or implants has become commonplace, with devices readily available to attackers. Here, a member of the maintenance crew has been coerced into bringing a device on board during scheduled maintenance. Most modern vessels have some form of Wi-Fi coverage, so the attacker will have captured the Wi-Fi credentials and pre-configured the device to work on the ship's network. The device, once on board, would establish a backlink to the attacker's command and control servers. In many modern vessels, the engine runs at a constant speed, and the speed or direction of the ship is determined by the pitch of the propeller. In normal operations, instructions from the command deck are sent to turn the engine off or on, and to adjust the pitch of the propeller. With the implant in place, the attacker can carry out detailed reconnaissance, scanning the network with zero visibility to the ship's crew. Once the reconnaissance is complete, the attacks can begin in earnest. The attacker is now able to intercept genuine commands from the propulsion control system and replace them with a series of alternative actions. An invert attack would cause the system to do the opposite of what was expected. Engine on would mean engine off. Full ahead would mean full astern. An alternative attack might involve reduced thrust, so an instruction for full ahead may only deliver 50% thrust. A pitch to zero attack would set the propeller to zero, leaving the vessel effectively dead in the water. Now let's see what happens when the vessel is equipped with Orthos. Project Orthos is a unique collaboration between Cybersplice, Senetas and U-Bar technologies. Designed specifically to protect operational technology networks, such as those found on naval vessels, from an expanding cyber threat landscape. Orthos is a novel, active cyber-physical protection solution, featuring military-grade encryption. Orthos is available in a variety of form factors, either as high-assurance hardware or as a virtualized device. While it sits on the network, it is transparent to the rest of the infrastructure, with near-zero latency and overhead. Here is the dashboard for Orthos. At present, everything is green, as it knows nothing about the environment yet. Orthos can operate in two modes. In mirror mode, it provides visibility of what's happening across the network, but doesn't affect the outcome. When we turn the system on, we can see activity coming through. If we simulate an attack, in this instance an invert attack, where backwards becomes forwards and forwards becomes backwards, the abnormal behavior is picked up by Orthos. However, the system is capable of picking up this activity before the attacker has had the chance to establish control. If we go back to the point where the attacker is running systems reconnaissance, with Orthos still in mirror mode, we can see it has identified the initial recon. It is even possible to visualize the attacker's behavior and see where traffic is being sent across the network. Having identified the threat, what can be done about it? Can we prevent the attack from happening? The answer is yes. Let's simulate the invert attack again, but this time with Project Orthos in in-path mode. As you can see, the attack is in progress. However, with Orthos in in-path mode, It prevents the attacker from accessing the engine control module. Even though the attack is still in progress, the command and control equipment has been shielded from the attacker. Where other solutions only detect attacks already in progress, Orthos actively prevents cyber-physical attacks from happening. It does this by shielding vulnerable equipment inside an encrypted overlay network, disrupting the kill chain of would-be attackers, and putting control back in the hands of the captain and crew.